Here today. I understand it's the 11th Night of Nordics. It's actually my second. I was here last year, so it's a great event, and it's always very energizing to engage with others in the ecosystem, particularly startups, new companies that we don't traditionally talk to or collaborate with, and that's actually what we want to accomplish here today. I'll give you a short overview of what Bell Labs is all about, and maybe some of the things that you would not expect necessarily the research arm of Nokia to be working on, but some of the really exciting technologies that we work on. And then really this is about us telling you some of the technologies we're working on, and we're really looking for collaboration. We're really looking for collaborations that help us take these technologies out of the labs into commercial applications and the real world. So you probably know Bell Labs as the research arm of Nokia. We have almost 100 years. In 2025, we're celebrating 100 years of Bell Labs. And we've always done research in the direction of the portfolio of the company. So whether that is in networking, in wireless, in IP, in optical, in fixed access, broadband, and so forth, we always do research 3, 5, 7, 10 years out in the direction of the company. But we also look at what are the fundamental problems of our generation. Throughout the history, we always look at what are the defining technologies and the defining problems that we need to solve to change how people live, work, communicate with each other, and more how people communicate, interact with machines, or maybe machines interact with each other. So for us, it's always about starting with the industrial problem, the societal, the human problem that we want to solve in a disruptive way. Because if you solve something in a disruptive way, you're really creating innovation. It's not about doing something incrementally. It's really about solving the foundational problem. And we've done that through our history, and I'll just give you 4 examples here because they are relevant to some of the other themes that we'll be talking about today. The most famous invention of Bell Labs is still the transistor. So after 75 years, we haven't beat anything come up with anything that beats the transistor. So that's still the single biggest achievement in Bell Labs history. Also information theory, and you see a picture here of Claude Shannon, who's the father of information theory, which really opens up the digital information age. But also interestingly enough, Shannon was working on AI and machine learning problems, which are of course very relevant today. Unix, C, C++, invented in Bell Labs, very relevant for our computing age. And then Jan LeCun, when he was at Bell Labs, invented convolutional neural networks, which are, of course, very, very important for AI machine learning today. So we've always looked at these foundational problems and disruptive technologies that fundamentally change the game of our generation. So now you could say, what's the challenge of the current generation? If I say we always look at the foundational challenges of our generation, what's the fundamental challenge of our current generation? And we believe that the 2030s will be marked by a fusion of the physical, digital, and human worlds. And of course, that's already happening today. We're all people, we live in a physical world, we have digital presence, but I'm not talking about better social media. That's not what I'm talking about. I'm talking about in our enterprise, in our industrial environments, in our everyday life, how do we blend the physical and the digital to improve productivity, efficiency, safety, and sustainability? And that has implications for the future of work, the future of collaboration, the future of co-design, but also the future of industrial automation, for example. And if you want to do that where we create digital representations of our physical world, including us as people, we want to create digital representations of us as people to better understand our well-being, our physiological, our cognitive well-being, so that we are healthy, well, wealthy too, but that we're healthy and we're maximally productive. But we also want to understand how we operate best in our environments. So we want to create digital representations of physical environments, optimize those, and then improve back into the physical world. So there's a loop between the physical and the digital world. And what is very different going forward compared to the past is that the loop becomes faster and faster, how we interact between the physical and the digital world. And the interactions will become more complex. We're not talking about small optimizations between physical and digital worlds, but really at large systems. So when you think about this reflecting a digital twin, for example, we've had digital twins for a long time, but we talked about digital twins of, say, an engine on a plane, and we've built CAD models and 3D representations of engines, but we're not talking about that anymore. We're talking about a digital twin of an entire plane, an entire airport, maybe an entire city, maybe even the world. So the scale of these digital twins becomes much larger, the complexities become much larger, the number of stakeholders become much larger, the amount of information that needs to be shared between the different stakeholders become much larger. There's different business relationships, different trust relationships, and all of this will be optimized through AI systems. Ultimately, all of this requires networking capabilities, so that's where we see the evolution from 5G to 6G to have really the advanced networking capabilities that allow us to share all the information and connect everything, but ultimately it's not just about the network, it's really about the application and the business problems that you're solving. So that's kind of what we see as the future for the next 10 years. And a lot of the research in Bell Labs is geared towards, on one side, the future of communication and computing, but also the future of automation and analytics as it pertains to enterprise and industrial applications. So going beyond connectivity to see what are the applications, the services that run on top of the network to provide these business values. So before I go on to tell you a little bit about the topics that we selected today to share with you, I want to talk just a little bit about maybe the Bell Labs innovation model and how I think about the life cycle of innovation. If you think about the innovation, it really has three phases in my mind, and happy to get your views during the networking session. I think it starts with the fundamental idea, the ideation, the research. You're not sure, but you see a problem, you want to solve it. So that's kind of the left-hand side, which is really about solving the hard technical problem. Then the middle part is really about what I call the innovation and the acceleration. Now you have that raw technical idea, you solve the problem, but that solution can probably be applied to a large number of applications and use cases. So now you have to pick, how do you apply it? How do you take it from a lab to a real world? How do you apply it to an actual business problem? At that point, you haven't commercialized it, but you're now sharpening the focus of your technology to a particular domain, whether it's a particular use case, particular vertical application, particular customer segment. You refine your idea to solve that particular challenge in the real world. And then on the right side, then the last part is now you have your product, you have your market, you commercialize the product, and you scale up. So typically Bell Labs is working very much on the left side and more in the middle side. So we're very, very good at the research part, the ideation, the solving the hard technical problems. We're trying to do more and more on the innovation acceleration side, but quite frankly, that's the part where we're struggling. And that's really why we are here today and why we want to talk to all of you. Because we're very good at solving technical problems, and I would say that's where you create inherent value, you solve the problem, you have that technology, so you created the value, but you haven't captured it. And you haven't decided yet how you want to capture the value out of your idea. So we are really looking to engage with all of you to find the best ways possible to take the technology out of the labs into the real world, into commercial applications, develop business models, develop business cases, develop go-to-market strategies, whichever market segment we might choose to. We might have ideas of where the technology can be applied, but you might look at this and say, you got it all wrong. That's a cool technology. You think of using it for that use case. I think you should use it over here because that's a much better application. So we're really looking, and that's quite frankly the biggest struggle that Bell Labs has right now. We're very good on technology, we're not very good on the commercial aspect. So we're really trying to engage with entrepreneurs, venture builders, companies, startups, anybody that can take the technology and say, that's really cool, I know what to do with this, I've always thought about this problem, I didn't know how to solve it, now I see you have a solution, I know how to take this solution, I know how to create a market for it, or capture a market. Let's work together and bring that solution out of the lab into a real world solution and put it on a track and a path to commercial success. So that's really our ambition, and that's really why we wanted to be part of the event today. We're not looking for funding initially. Of course, if any of you want to fund the ideas and accelerate and speed it up, absolutely we should have that conversation, but we're more looking for any of you have ideas to saying, I know what to do with the technology, and you have a great idea, but I have an even better idea of what to do with it. So we picked 4 topics and that we want to share with you. The first one is around fundamental building blocks in AI. for really creating this physical-digital fusion, that duality between the physical and the digital world. We'll talk about technologies for indoor localization and tracking of things, assets, people, objects, machines. We'll talk about robotics and how we turn robotics into cloud and cognitive robots, blending the onboard intelligence in the robots with cloud intelligence for robotics. And then we'll talk about devices, end devices, ultra-constrained devices, ultra-constrained in their power and their communication and compute capabilities, and how do we build an efficient operating system to bring AI and software capabilities to those constrained devices. So I will pause here. I will turn it over to my colleagues who will share with you a little bit more about each of these ideas. And then I hope that we have lots of